Hello, my name is Kayla Dawson. Today I will explain the fundamentals of cloud computing and the related security issues from migrating cloud services into a network. Cloud computing is the delivery of computer services by a host over the internet. These services allow users to access data in cloud applications from remote physical servers, databases, and computers. The primary cloud services offered in cloud computing are infrastructure as a service, platform as a service, and software as a service. Private, public, hybrid, and community are the four commonly used cloud deployment models. Cloud computing is built on top of virtualization technologies. Virtualization provides the cloud power in delivering services to end devices over the internet. Automation capabilities allow users to self-provision or provide the resources and services they need without human intervention. Some advantages and features of cloud computing are automation and orchestration, where users can control the amount of network storage and server time required for deploying tasks or dictate where they want to move applications. Cost management, as cloud infrastructure reduces costs towards fixing downtime related issues, and users are charged only for the resources they use. For example, you can subscribe to Google One for 100 gigabytes of cloud storage for $1.99 a month. With performance monitoring, users can analyze the metrics of servers, cloud-based applications, and databases. Cloud vendors also provide virtualization platforms in their services, such as Google Cloud Compute Engine, where users can create and run virtual machines in Google's infrastructure. Three primary types of cloud services are infrastructure as a service, software as a service, and platform as a service. Infrastructure as a service is a cloud service model where a third-party vendor hosts virtual servers, instances, data storage, and application programming interfaces, which allows users to transfer workloads to a virtual machine. Infrastructure as a service vendors have a pay-as-you-go subscription model to provide services at a low cost. For example, Amazon Web Services charges cloud services based on the length of time and the number of resources used. Software as a service is a cloud service where a third-party vendor provisions and hosts software applications over the internet. These applications can be accessed and used from any location by a mobile device or computer if it has access to the internet. Microsoft 365 and Datadog application performance monitoring are two popular cloud services companies use for productivity and performance monitoring for web services. Platform as a service is a cloud service where a third-party vendor provides software and hardware tools for developing applications on its platform. As a result, users can run, develop, manage, and test their applications. Google Cloud Platform and Microsoft Azure provide a cloud environment and the tools developers need to create, test, manage, and deploy applications at their discretion. Another cloud service that falls under the category of cloud computing is desktop as a service. Desktop as a service is a cloud service model where a third-party vendor provides desktop operating systems and applications to a user's end devices, where the user accesses the services through client software or web browser. The vendor handles the back-end data storage, backup, security responsibilities, maintenance, and infrastructure costs in providing virtual desktop services to users. The user manages the desktop services, such as virtual desktop images, applications, and security, unless they opt into a subscription plan where the vendor manages it. Citrix Managed Desktops and VMware Horizon Cloud are two of the best-known desktop as a service vendors. They both offer a starting price of $8 per month and multiple support tiers through their respective client software. Four commonly used cloud deployment models: private, public, hybrid, and community. In a private cloud model, an organization builds and maintains its cloud infrastructure where access to services is internal only. For example, VMware and OpenStack are two common private cloud technologies and vendors whose cloud services are strictly for internal users. This model is dedicated to the needs and goals of a single organization using virtualization software. In the public cloud model, a third-party vendor owns cloud infrastructure components and distributes services to the general public. Amazon Web Services, Google Cloud, and Microsoft Azure are cloud vendors that use this model. The hybrid cloud model combines public cloud services and on-premises private cloud services through the integration of automation and orchestration. For example, an IT admin from VMware could use their internal cloud services to run sensitive or critical applications and use Amazon Web Services to manage spikes in computing resources. The objective of a hybrid cloud is to build a unified, automated, and scalable environment that takes advantage of everything a public cloud infrastructure can offer while retaining mission-critical data management through a private cloud. In a community cloud model, multiple organizations that are part of a community share cloud computing services. For example, 2 universities working together on a joint initiative uses Google Cloud Platform to manage applications and workloads. Service-oriented architecture is a software development methodology that uses software components known as services to create business applications. Each service performs a unique business function and can communicate across multiple platforms and languages. This allows developers to reuse services across many platforms or mix multiple distinct services to perform complex or critical tasks. The benefits of service-oriented architecture in cloud computing are the ease of maintenance in creating, updating, and debugging applications, adaptability in using old systems with new cloud technology, and assembling applications more quickly than writing code from scratch. One of the most significant issues with cloud computing is data storage security. Third-party vendors are storing user data and processing it on their end, which means the user has no way of seeing how the data is secured. Poor security configuration and lack of authentication controls can result in data breaches, ransomware attacks, or data theft. Some vendors include in their privacy policies that user data can be accessed with or without permission by the user and delete their information. To stay in compliance with regulations and rules from the General Data Protection Regulation, Federal Information Security Management Act, Health Insurance Portability and Accountability Act, or California Consumer Privacy Act, vendors and users as a shared responsibility will have to make sure that they are hosting data and users' personal information in compliance, or they will be subject to penalties or sued for illegal use of data. Cloud servers are susceptible to attacks such as ransomware, data breach, exploitation of misconfigured servers, and lack of authentication controls to protect databases from unauthorized access by threat actors. To protect cloud computing and reduce the cost of suffering a cloud attack, implementing the following security measures would mitigate threat actors from executing cloud attacks. Provide user awareness training for staff. Ensure that quality control checks are carried out by IT departments or cybersecurity personnel to make sure that servers are correctly configured. Follow principles of zero trust, where access requests are verified before granting access to the network. Implement multi-factor authentication and conduct routine penetration tests to test cybersecurity posture. It is imperative that there are strong layers of security in place to protect the confidentiality, integrity, and availability of cloud resources.